get going. So what is the topic that we're doing at the moment? We're doing circle geometry, and we spent the last week talking about circles and theorems related to the center of the circle. And today we're going to shift our focus to circles and cyclic quads. But before we do that, I want to do some vocabulary again quickly. So I want you to tell me in the chat what this yellow line is called in circle geometry. Okay, so I see lots of students who know this. A line across from one side to here is called a chord. Now, what do we call this area over here that I'm coloring in red that is divided by the chord? What's the fancy word for that area over there? Going a little bit deeper here. Okay, so it's not a sector, but you're close. I'll talk about what a sector reminds me of an orange, which this doesn't remind, yeah. Okay, so yes, the fancy word for this is called a segment. And this is called the major segment, and this is called the minor segment. Would anybody like to jump on the line and tell me why the one is called the major segment and the other one is called the minor segment? Who's feeling like they can tell me why they're called segments, major segment and minor segment? Okay, so Nele, you're quite right. The major segment is the bigger one, the minor segment is the smaller one. Now, there is a theorem today that we're going to talk about, which is the shorthand version of this theorem is called angles in the same segment. And when we talk about angles in the same segment, it's important we know what a segment is. Like there's a segment on the one side and there's a segment on the other side. Okay, let's do a little bit more vocab before we get going. What is this pink line called? It's a curved line. And you're quite right, this is called an arc. And this too can have a minor arc and a major arc. And again, it just comes down to the size. So the green one is the major arc and the pink one is the minor arc. Okay, so that's a bit of vocab. Now in the chat, there was a conversation a little bit about what a sector is. A sector is not as commonly mentioned as the segment is, but a sector is basically the area enclosed by two radii in the circumference. So that would be, you also get a minor sector and a major sector, but it's slightly different. It's like the pizza slice. Okay. All right, so that is our little bit of revision today. So now we're going to talk a little bit about theorems and facts about circles that deal with a cyclic quad. So let's first talk about quads. Well, quadrilaterals are four-sided shapes. So if we think of a quadrilateral that you learned about in grade 10, there's many different types of quadrilaterals, but the most basic idea is that they have four sides. So when we talk about a cyclic quad, it's a quadrilateral with four sides, but what is the cyclic thing means? And the cyclic thing just means that the vertices of the quadrilateral are on the circumference of a circle. So that would be a cyclic quad. And normally we would label the points or the vertices like A, B, C, D. But we can also get a cyclic quad that looks a bit odd, like you could have one that looks, like that. That would be a cyclic quad. And you could even get other types of shapes involved in doing that. Okay, so does everybody understand what we'll call this one? let's call this like A, B, C, D. Give me a thumbs up if you understand what a cyclic quad is. Thumbs down if you're unsure of that. Okay. Okay, so there's a couple of different mixtures. So let me jump to a visual before I do that. We're gonna do something else later in the lesson. Okay, let me show you what I mean by a cyclic. Where did it go? Okay, so this is from later in the lesson, but I just want to show it to you now because I think people are struggling to visualize what a cyclic quad is. Okay, don't worry about the numbers, but can you see the shapes that I'm making with this? Can you see how the 4 points are all on the edge? So this is an example of a cyclic quad. And that's all I kind of wanted to show you so far. So as long as the 4 points are on the outside, or on the circumference of the circle, it's a cyclic quad. Let's go into a little test about that before let's go. Okay, so let's have a look at these questions here. If you look at the first drawing, we have a cyclic quad here. Okay. If you look at this one, that's fine. But if you look at this one over here, this Q, this point, WQPR is not a cyclic quad because the 4 points aren't in the circumference of the circle. And this one over here, so this is not, and this one is also not because this point is at the middle and it's not on the edge. Give me a thumbs up if you understand what a cyclic quad is now. Give me a thumbs down if you don't understand what a cyclic quad is. Okay. So I think that helped a little bit in just clarifying what I meant by a cyclic quad. For those who don't yet get it, don't worry. We're going to come back to it later in the lesson. I just wanted to establish this at the very beginning. This is going to be the sort of more the second half of the lesson, but let's just go to another theorem first. Okay. So the first theorem for today relates to this picture that I'm going to show you now when it comes out here. And let me zoom in a bit. Okay, so if I look at this theorem, you will see it says angles on the same arc are equal. So just take a moment to look for the red line. If you look at the red line at the bottom, so let me draw a circle. And let me draw this red line at the bottom, which the shape is trying to show you. Okay, so this is the first new thing for the day. And what you'll notice is we're not particularly worried about the center of the circle at this point. The center is being ignored, but this is, the red bit is an arc. And if I draw, or I use the arc to subtend an angle up here, and then I use that same arc to subtend an angle up here, what shape does that look like to you? Before we even start asking questions, what shape does that look like to you? And if you like, you can put your hand up and we can hear you audibly, but what does that remind you of? You just said like pattern association, two triangles or hearties. What do you think?
I was going to say the same thing, two triangles.
It looks like two triangles, absolutely, two triangles. And if you really want to get more arty, it kind of looks like a butterfly. Would you guys agree? Like two triangles or a butterfly. So it turns out a lot of people refer to this as the butterfly theorem. You can kind of see it looks like the two triangles are the wings of the butterfly. And so what you see is that you've got the 4 points that are on the outside. It's a cyclic quad. But the main thing that's important for this theorem is that you basically are seeing that when you have an arc that subtends an angle from the same arc, those 2 angles are going to be equal. Now, some teachers refer to the chord between these 2 points as being the bit that subtends the angles. It doesn't really matter. But the main idea is you're taking this piece of a circle and you're allowing it to be the base, and then you draw 2 angles at the circumference from it. And 2 of those angles will always be equal. Now, I know it's a mouthful, but let me just show you what I mean. Watch the live drawing now. Can you see how I can make the butterfly look quite different, and yet the angle stays the same? Now, that's kind of weird, eh? So that's called, the theorem is called, well, we're not doing too many reasons yet, but the shorthand is angles in the same segment. And that's because they are in this, these 2 angles are in the same segment. So that's part 1. Okay. Now, we're going to do a little practice question to show you how this looks in person. But just to remind you, we're going to come back to this later. These 2 angles down here are also equal. So in the butterfly, the top one here is the same as that one, and the bottom one here is the same as that one. But I'll come back to it in a moment. So let's look at a typical question. So here's a typical question. I want you to tell me in the chat, what is x equal to in this particular circle? Okay, now, yeah, so it's not actually that hard to apply. I think it's harder to explain. But if I was telling you or if I was wanting to show you what is the arc or the chord on which this theorem is based, the arc that it's based on would be that one. Or we could say the chord between here and here is the base, and this subtends the angle 40 up here. And so this one over here must also be 40. Okay, so that wasn't so bad. So let's see how we apply this theorem in, say, slightly more interesting examples. Let's do 2 more. So I'm going to call this number 2. I'm going to call this number 3. And I want you to try and do question 2 and question 3 for me. Aha, Dalakombi, the reason I didn't talk about the arc on top is I didn't want to put too much out there at once. So I'll talk about the other arc in a moment. It just felt to me like it was too much if I mentioned the other arc at this beginning stage. Okay. The people are speaking and they are saying that x is 70. And you are quite correct. X is in fact 70. Now things get a little trickier for number 3. We need to find x and we need to find y. I would love, there are some people giving answers for x. I'd love some students to tell me their thinking as to how they got to their answer for x and for y. It's really helpful. It doesn't really matter if it's wrong or right. If you just show us the process you were thinking through. Would anybody be willing to share their thinking? I see some good words. I see some interesting numbers coming out. But what I want to know is about the journey. I want to know about the journey. Sololela and Ratabile, what are you thinking? What are you thinking? Rafiwa? Sechava? Isona, what do you think? How did you get your X's?
Seems they're a little shy today.
No problem. So, Sinuyolo, alternate angles. I definitely see alternate angles. So yes, So there's a couple of ways you could do this, but I think for a lot of students, they may recognize these parallel lines and see that x is 50. So that is step one. But now, if I've got x is 50, what is y going to be? Hearties, let's go to you.
Yes,
Hey.
y is equal to what you call it, 130.
130. Okay. What were you thinking about getting? What did you use to get 130?
I took 180 minus 50 because it looks like a triangle. That's why.
Ah, triangle. Okay. So I do see, but now if you had the 50, okay. So Hearties, you're right in most of the way, because you know this one and this one together must give you 130. But the problem is I want only y. So I agree with you that these two angles together are 130, but I want only y. So can anybody help us along? Thank you, Hearties. That was a nice bit of thinking. Sequenza said y is 40. I'll give you a little hint. Okay, I'll give you a little hint with this one. Imagine that you are thinking of this arc over here as the arc on which you're going to subtend an angle. So you're going to use that as your base, and that's going to be your helping thing. Okay, Rafiwa, let's go to you. What do you think? Can you hear me, Rafiwa? Hey,
Hello, sir.
how's it going?
I'm fine.
Very good. What are you thinking with y?
I think 90 minus 50. I think it's 40.
40. Okay. Where did you get the 90 from?
From
Just
the
curious.
from the Y.
From the y. Okay. So I know in the last lesson, we spoke about angles in a semicircle, but at this stage, we don't have any center of the circle. So I'm going to give one more hint to everyone to help you along this process. If you look at this angle over here, don't you think I can, oh, that's a bit thick, isn't it? Maybe I should use my highlighter. So if I go like, I think I can see that yellow bit, the yellow angle is subtended from the pink one, and I get 50. And I'm thinking something's feeling a bit familiar now. Sinuyolo, what do you think?
Because it's angles on the same arc, I think
Yep.
it would still be 50 degrees.
You are correct. Ding, ding, ding. Okay, it totally is 50, but why is it a bit harder to see this time? Sinuyolo, it's a bit harder. I don't know if you,
Okay, so it's harder now because we have like alternating angles, because
yeah,
like usually our first example, it was on the same, like it was X and Y, and now
yeah.
it's like shaped differently, and it's like, yeah, basically.
There's a lot more going on, basically. There's a lot more going on. So one of the things that I think is knowing that the arc doesn't always have to be at the bottom. So you don't have to focus on, like, it's not wrong, right? So if you focused on this arc, then you can know quite quickly that this and this is 50, but that's not really where you wanted to focus. What you wanted to focus on was figuring out y, and the one that y is related to is this one over here. And we did the first step to get x was 50 with alternate angles, and then we got y is 50. So it's the same shape, and the shorthand reason, now I'm not focusing on reasons in this course, I'm just focusing on shapes, but it's called angles in the same segment. That's the shorthand reason, and it's the same theorem that I've been talking about a lot so far. So Sino has asked, how would I know which side to use the arc, top or bottom? it depends. It doesn't change. Well, it depends on what what you want. So if you wanted something at the bottom, you kind of would use the one at the top. And if you wanted one at the top, you'd normally use the bottom. It's kind of the opposite way around. But you'll see with more examples, you'll find this easy. The main idea is seeing the butterfly and also realizing that when the butterfly happens, and I'm not emphasizing this too much, but look at how these 4 points, they are on the circumference of a circle. So they are making a cyclic quad here. So it's not just any butterfly that behaves like this. It's butterflies that are on a circle. And I don't want to overload you at the stage, but that's an important idea as well. Okay, let's have a look at something with a bit more detail. Now, don't have a heart attack because I'm only going to ask you to do a couple of these. Let's start by doing number 1. So I want you to tell me what your answer is for, I want you to find me A and B. I'll try and get these other ones out the way. Yo, look at that zoom. Yo. Find me A and B. And while you do that, I'm going to get some water. Let's see what I can do here. So it feels to me like A is 27. And you know what? You don't even have to draw this arc all the time, but to find what B is, you can imagine me using this one and then going, well, that angle over there and that angle over there must be the same. But when you're first starting, it's very helpful to imagine the arc at the top, the arc at the bottom. So B is going to be 30 degrees. Okay. And that's what I'm seeing in the chat for the most part. So I'm feeling good about that. Can we do number 2? I want you to find me C and D. I like what I'm seeing.
Mr. Ace,
Yes.
Bianca's asking if you can please explain number 1 again.
Okay. Well, I tell you what, Bianca, let's go through number 2 together, and a similar idea will come through. So in number 2, I've got to find angle C. And we're going to use the theorem that says there's an arc, there's a shared arc, but whenever we see this butterfly shape, and in the butterfly, the 4 points are on the edge of the circle, we can imagine that there's a shared arc over here. And that arc is going to make one angle over here, which we're going to call C, and another angle up here, which it looks to me like it's 20. And so those 2 angles are the same. And so we say that C is 20 degrees. It's like the 2 parts of the butterfly there. So that's how we get C. Does that help a bit, Bianca? Maybe just give a little private message or message to label. You're basically using that. Now, after a while, you start to spot a pattern where you can see the sort of which parts of the butterfly go together. But if you need to, after you found what C is, you can also find D by thinking about, you don't have to do this, but you can think that this is a shared arc up here, and you can find that this over here is going to be equal to this one over here. And so D would be 45 degrees. Now, again, in practice, once you start to see these shapes all the time, we don't generally draw both arcs. We start to see kind of that this one goes with this one, and this one goes to this one, and we start to just sort of see it. But until you see it, it's really important that the main ideas are there and we keep doing it. Okay. The arc can actually be anywhere. So there's a couple of questions about where the arc needs to go. If you think of a circle, if you want a butterfly, what you need to have is just to have 4 points on the circumference of the circle. And then all that happens is that they essentially do that. And then you join those lines like that. So there's nothing particularly, the arc will come from whatever angles you're focusing on. So if you're focusing on those two angles over here, then the arc that is relevant will be down here. Oh, it looks like a person who's like, looks like a, I don't know, I was gonna say transformer or something. I don't know, maybe I'm being too imaginative. But yeah, okay, so I hope that helps you a little bit. Okay, everyone, we've been going for half an hour and I think we've made some good progress, but we need to also give our brains a break. And so what I want to invite you to do is to join me and just stand up for a second. And actually, you know what? Don't even stand up. Let's do something. Let's do the thing we did the other day. Let's do this thing. So we'll do a quick little breathing exercise just to give ourselves.
So sitting comfortably, just taking a big, deep breath in through the nose, out through the mouth. As you breathe in, noticing how the body expands. As you breathe out, just watching the body soften. You gently close the eyes. And rather than the mind leading the breath, allow the breath to lead the mind. Notice the sensation of the breath. Notice it where you feel it in the body. If you need to, you can just gently place your hand on the stomach. And just following that rising and falling sensation. Nothing else to do. Allowing thoughts to come and go. And when you're ready, just gently opening the eyes again.
Cool. Give me yeah, I'm always curious to know how people found that. It's a little 1 minute brain break sort of breathing exercise. Yeah, let me know in the chat. How did that feel? I always feel a bit more relaxed after one of those. But everyone's different, so no judgments either way.
I'm gonna go almost fell asleep.
Okay, well, I mean, that voice, how nice is that voice for just like
Yeah,
unwind?
very soothing.
Okay, let us try and solve a Math 24 puzzle. So you have a red and a blue one, and what you need to try and do is take these 4 numbers and try and make 24 with them. And you're only allowed to use plus, minus, times, and divide. So see if you can make 24 using the red card. Let's leave the blue card for now. Let's all focus on the red. And that's a 6, in case you're wondering. Some answers are coming in. See if you agree or disagree. Okay, so I see quite a few ways. 5 times 3 plus 5 plus 6. That doesn't quite get us there. But what I am seeing is 5 times 6. So I use these two to get 30. And then I say 30 minus 3 minus 3, and I get 24. 5 times 3 is 15. Oh, that works. Or you could say 5 times 3 is 15. And then 15 plus 6 plus 3, which is 24. I see a couple of students got it like that. Thanks, Ayole. And fantastic. Okay, let's try and do the blue one. Let's see if we can do this one. That's a 9 this time. The bar is always at the bottom. Can you find me 24 using 9, 5, 8, and 4? So for those who are feeling a bit confused, we have to use each number once, and we only allowed to use plus, minus, times, divide, and brackets, and we're trying to make 24. That's the aim of the game. What can we... So Ania said 9 times 4 is a good step to use in this one. So 9 times 4 is 36. And then if we go 36 minus 8, we get 28 minus 5 is 23. You got very close, Annie, but I don't think that's a cigar yet, or excuse the pun. Okay, so we are going to leave this one for now because it's a nice challenge, but you got close, Annie, and then we'll come back to it at the end of the lesson if someone has figured it out, but I don't want to spend too long on this. But yeah, well done. So it's a great game for just working on your mental kind of memory and stuff like that. Okay, let's go back to these ones. If we look at these questions, let me go to 4. So I want everyone to try and do number 4 for me. So try and solve for F, for G, and for H. There's quite a lot going on in the drawing, and there are no parallel lines here. All I've got is the butterfly shape and in a cyclic quad. And that's about it. I'd love to hear how, because there's quite a nice variety of answers, which tells me something interesting is going on. I'd love to hear some of the thinking about how you got your answers, if you're willing to share.
We'd
Okay,
love
but
to
guys,
hear your voice, guys.
Yeah. Because there's no parallel lines here. Like in the earlier question, we had something like that, but that's not in the game. Sia Takosa, let's go to you. I'd love to hear your thinking.
Hey, sir.
Hey.
So I think F will be 40 because of the opposites, because they are in the same segment.
Okay.
And
So you're saying F was
40.
40. Okay, let's have a look. So if that was my arc, then this would be the angle over here. And this would be this one over here. Yes, I agree with you. So I think that F is 40 degrees because I can see that this and this one go together. Lovely.
Yes.
Thank you for your question. Now, what about G? And let me fill in the 40 here. How do we get what G is? Maybe Luyanda, let's go to you. Luyanda, how do you get what G is?
Hi, sir.
Hey.
So for G's, I said G equals to 180 degrees minus brackets 14 plus 85, which is interior angles of a triangle. And then I got 55 degrees.
Yeah, I agree with you. So that is, Luyanda, that's great. So what Luyanda is doing is the 40 plus 85 are these two. And we know that this whole thing must add up to 180. So that's why we end up by saying that G must be 55. So G is in fact 55. Now there's one more thing that we need to get. It's H. How are we? There's a couple of ways we could figure out H. There's a short way and a long way. Umta, let's go to you. What do you think about how do you find H?
Hi, sir.
Hey.
So I think H is going to be 55 degrees, if I'm not mistaken.
I agree with you, Umta, because, and even if I just so my brain can see it, I mean, I'm pretty confident because of the butterfly, I can see that relationship. But this one over here must be the same as that one over there. And so H is indeed 55 degrees. Well done. We're getting some harder ones now, huh? Well done, everyone. Okay, let's take a screenshot if you need to, because we're going to go on to another one. But I'm definitely seeing the visual skills are starting to come. And that's why once you've got the visual skills, you can learn the reasons later. But you need to get that visual awareness of what's going on first. Otherwise, your brain goes, no, too much going on here. Okay, let us try.
Mr. Ace,
Yeah.
is it possible to explain why in the previous one F and G can't be equal?
Okay, let's have a look. Why F and which one?
F and G
can't be equal.
Yes.
Okay, so if we look at where F and G are hanging out, they're in this triangle over here. So here's F and here's G. Now the problem is, if this was the center of the circle, then those two would be equal. But they're not. It's not the center of the circle. It doesn't. In fact, you can visually see this one is actually longer than this one. And so because this isn't an isosceles triangle, there's no way that these two could be equal. That's kind of my best way I can describe it. Okay, so I hope that was helpful. But nice question, because a lot of students assume it's the center, and then you have to ask that question to know. Okay, let's do
Thanks,
number.
Mr. Ace.
Pleasure. Let's do number 5 and see how this goes. I want to find A, C, and B. Okay, so I see answers coming through, which is good. And just to point one thing out, notice how in today's exercise, we haven't really had the center of the circle involved at all. So, you know, when you look at these questions, it's often a case of recognizing what are the information that's given to me, what are the facts or ideas that I need to apply to the situation. And I like to group the facts into 3 containers. of which today's all about the cyclic quad. So I'm feeling like A and 32 are definitely in a relationship here. Like, I'm drawing a little bit less information than before. So A is 32. And I feel, well, I don't just feel, I know. B is 80 degrees. Now, what about the other bits? Can you figure those out? C is a bit nasty. Who wants to share how they got to C? Because I want to see what's going on. Who will share with us their journey to C? Because there's some nice debate. There's C at 65, C at 43. There could be lots of things going on here. Nokozola, Feliciwe, Leviwe. Come on, I know you want to give it a go. Basedi. Who else?
Who would like to share their wisdom with us?
Or just their thinking. I mean, you don't always know this because you're not the teacher, but it's not really the answer so much as it is the thinking that goes into it. The answer is just like the end of a story. But the most exciting part is like the journey.
Yeah.
Okay.
Anybody?
So, I don't want to steal your guys' thunder, but I'll give you a big hint. Luyanda.
Oh, we have a hand from Luyanda.
What did you get for C and how did you get it?
So for C, I got 43. So
43?
what I did was I made the triangle we just use as red, so I made it one triangle. So I said C equals to 180 degrees minus 80 degrees. And then in brackets, I said 32 plus 25. And then subtracted that, and then I got 43.
And you got, what was your final answer? 43?
Yes, sir.
I agree with you. Because you've just used an idea about a triangle that you've known about. It's just that the triangle is living in a circle now. And so it looks a bit more complicated. But yeah, that was nicely done. So what I want to point out to everyone now, because we're going to start finishing off, is how far we've come. So when we started today, we learned about a circle and we learned about this new theorem we're going to call the butterfly theorem, which is really just using a common arc to subtend angles. But then it's almost like we start to mix in the other geometry that we know. So things like the sum of angles in a triangle, or when we have parallel lines, we have shapes. And so it's important that we build up our knowledge gradually and then keep remixing and going, okay, how would this interact with the other stuff that we've learned about? But because we've learned a lot today, I'm actually going to bring this lesson to a close now. Lebo, can you put the poll out for the students? And then if there are any final questions anybody would like to ask, now is a good time. I'll go over anything from the lesson. But yeah, and if you could just help us by giving some feedback about how the lesson was, that would be awesome.
We really appreciate your feedback, guys.
Are there any final questions before we bring our time together? Oh, yes, Boypelo, I'm so glad you enjoyed your first class. And remember, Boipelo, we also we did 2 lessons before this, so I'd really encourage you to have a look at those lessons. They have a very similar format to this, and yeah, they're on the Watobe website. But yeah, Nkosi, thank you. I'm glad you enjoyed your time. And on Tatile, what is your question?
Hi, sir.
Hi, how's it going?
I'm good, thanks. Sir, I wanted to ask, I'm not quite understanding how we got C.
C. Okay.
Yes.
Are you happy with A and B? Do you feel like A
Yes,
and
I
B
am.
believe? Okay.
Yes.
The main thing to understanding how to find C is the red triangle. So if you look at the red triangle, can you see that?
Yes, sir, I can.
Okay, so now all triangles in the world add up to 180. And the good news is we know what this angle down here is. It's 80. And we know what this angle over here is. It's going to be 32 plus 25, which is over here. And so then the only remaining part is going to be C. So we go 180 minus the blue minus the green, and we get our answer, which is 43.
Oh,
kind of
yes, can see. Yes, 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 yes.
Okay, now I'm so glad I could.
Thank you.
Pleasure. Kakelo, oh, that's awesome.